Hello, everyone. Welcome to Karmada community meeting. Today is June 9th, 2026. We have several agendas today. So, Zhu Yu, you are on the first, so please take it away.
Okay, cool. Thanks. Okay, let me quickly share my screen a little bit. One sec. Are you able to see my Chrome screen?
Yep.
Okay, cool. Hey guys, I'm Joey. I'm working at Bloomberg, and I think today I would like to walk through this push mode token rotation issue. And I think I'll start from some quick context, and maybe after that, also summarize the current approach that have been brought up and also discussed, and maybe we can start more discussion from there. Um, okay, so for the context, I make this like very simple diagram. Maybe I can also just do like split view. So like, okay, yeah, I think basically for Karmada push mode, the controller manager needs to talk to the member clusters. And right now, like I think it always establish connection by just reading the token once and bake that token in so that it's reuse the same token for the whole lifetime of that connection. Um, and I think this is will be a little bit tricky because the token itself might get expired. For example, it might get like rotated. So in that case, for example, if the token gets rotated, we have some. My understanding is that we have like two patterns. The first pattern is that we have some like short-lived connections. So for those connections, for example, which is used by health check, for those short-lived connections, every time it talks to the member cluster, it starts a new connection to read like the fresh token. So there's no issue for the those short-lived connections, even though the token gets rotated. But we also have like those like long-lived connections. For example, I think Joe mentioned something like the informer here. The problem is that for those long-lived connections, because they only read the token once, so they don't know the fact that the token actually gets rotated. So I think in the end, the like we will get something like the partial failure scenario, which is like the short-lived connections are working correctly, so we can see that like the token is in ready status. But for any of the things that relies on the long-lived connections, it might not work correctly. So and I think specifically for our company setup, maybe I'll change the process. Yeah, I think for us, we have this component called cluster credentials provider. It basically manages the token that controller manager use
Mhm.
to talk to the like member clusters. It integrates with the token exchange service to get some like short-lived token. And right now to make sure like when the token exchanges, to make sure like all those long-lived connections can reread the token, I think Joe implements some like a workaround which basically compute the hash of the token and add it to the annotation so that when the token exchanges, when the token gets rotated, we like controller manager will see the annotation change to trigger like the whole restart. Um, and think this works, but we also notice that first of all, it requires like a relatively frequent restarts, and also because one controller manager may like talk to like bunch of member clusters, it seems like we will see like bunch of restarts at the same time, and a lot of them are actually like not really needed. Mm, okay, so maybe I should pause here, see if any question around the issue itself, maybe before I summarize the approaches that have been discussed. Okay, so if not, let me also go over the approaches that have been discussed. I think in this issue thread, there are currently four approaches have been brought up. I think one still needs a little bit clarification, but for the other three, they can simply be categorized into like two types. The first type, I would just call it like the rebuilding approach. I think it's basically when the token gets rotated, we just want to detect the token change, detect the change, and after that we just like tear down the connection and restart the connection to force it to like reread the new token. And I think there are two approaches, but I think they share the same mindset. One approach is like we add a secret informer to so that to watch that secret so that we know when the token rotation is happened. And another approach is like I guess similar to like the hash implementation that that we have in the workaround in the workaround is basically also compute the hash and put it into the cluster status so that we also know like the token gets rotated when it happens. But yeah, I think both approaches share the same mindset. But there's also another different idea, which is like instead of always just reading the token once, maybe we can just read those token periodically so that we can always get this token. I think we can probably do that with like a round trip by using the round trip. Um, I personally like this approach because first of all, it's something that is, I mean, it's like already well supported and there will not be many change. And also, to my understanding, comparing with like the first approach, which we might not avoid like a downtime. Basically, at the time we tear down the connection, create a new one, there will be like a maybe a very short window of the downtime. And but maybe with this approach, we could avoid that downtime. But yeah, I'm just curious, like if what are the different thoughts? Maybe there's a different approach or any like trade-offs people might think with all the existing approaches. Okay, yeah, I think that's all the summaries that I have. Yeah.
Mm. Thanks. I just realized that the workaround you are now using is uh what when you change the token, you need to restart the controller manager, right?
Yeah, this is what we're doing right now.
Yeah, I just realized that the workaround um is worse than I think because if you have many memory clusters, so you have to restart the controller manager uh, very frequently, right? So that's might not be acceptable.
Yes. Yes, I think you're right. So we saw like the spike of the CPU usage and we realized that okay, it's actually because like one controller manager restarts a lot of times and actually they're not needed. It's just triggered multiple times because the token of the member cluster gets rotated.
Mhm. So, just out of curious, how often do you rotate your token?
I
3,
think we do that daily, so basically 24 hours.
24 hours every day
Yeah.
means. Okay.
Yeah, so I think right now, yeah, this is what we have. Like we restart those controller managers like daily.
Wow. Okay. Hmm. So, currently, which approach do you tend to?
Um, yeah, I think so my personal preference is just to like reread the token maybe periodically. So which could avoid, tear down and create a new connection. But I also feel maybe this approach could introduce some like performance issue because we need to like periodically read the token. But I also see some other approaches like similar to the workaround that we have to basically detect um the token rotation and then just maybe restart the tokens.
Okay. Okay. Uh, just one question. On the approach you on your purchase. Does the informer need to be destroyed and be recreated after the token rotated?
Sh- I probably need to confirm more, but I think with that approach, maybe we don't need that because for that approach, basically we just leverage the round tripper so that every time
Mm-hmm.
we send a request, so I think this is the proposal. It's like every time we send a request, we leverage the round tripper to read the token, but also
Mm-hmm.
reading the token itself can be cached. So it's like even though every time we read the token when sending the request, but we also like maybe cache that token for like 30 seconds. So in the end, we probably only need to like really read the token, let's say after let's say
Yeah.
30 seconds or like 1 minute. So
So the
Yeah.
round tripper approach um, is a commonly used approach. I just wonder if there would be some negative implications of using it in this specific scenario because we are not using a client that is periodically applying things to some API server. We actually need a client to actually watch resources from the member cluster. And that watch needs a persistent long-lived connection to that member cluster. Uh, so I'm unsure of exactly what would happen to that watch when a new token needs to be used.
Um, Joe, I think that's what we solved at Bloomberg, right? You remember we talked about it with the secret store CSI driver and token bearer file.
Um, Bearer, yeah, so that's one option. Unfortunately, the using a bearer token file won't work in this use case because the controller manager needs to maintain connections to all registered member clusters, and it's actually not using the token from a file; it's using it from a secret that it loads from the API server.
But you could grab that token, right? And rotate that token and just grab it, put it in your client and connect to the member cluster, right?
Grab it from the secret.
Yeah.
Yeah, yeah. That's one of the options that ZU has been looking into. Honkai, what do you think about this? What
Uh,
recommendations do you have?
I think that this issue might be a common issue in Kubernetes,
Mhm.
like people or when people run a controller on Kubernetes cluster, and the token might be rotated by in the Kubernetes side. So I, I don't know how I don't know the best practice in Kubernetes, but I think that's a common issue. There must be there. I think they might have a practice for this similar issue. So basically, I like uh, Drew's idea with uh, round wrapper, so we don't need to destroy the informer.
got it. Okay. So maybe if there's no other uh comments, I will just summarize this and add another comment in this thread.
Able wrap the transport. It's able to rewrite the URL or something because maybe
Okay.
let us say maybe someday change the
Okay.
other field of the cluster. Then could this solution could handle that error?
Sorry, maybe I missed.
Yeah, my English is not that correct. And
No, I understand you. I think you just need to speak a little bit louder, but I think we can. Your English
Sorry,
is good.
Zhongqing,
okay.
I can
Okay,
hear you
I'll say
loud
little louder.
and
Yeah,
clearly.
I'll say little louder. Okay. I'm saying if somebody change the other fields of the cluster, maybe the API endpoint or the uh some other field or whatever, could this solution wrap the transport could handle that scenario?
I see. So if somebody changes for example, the URL or like but basically if somebody changed like configuration in member cluster side, uh,
That is a possibility. I don't think that would happen often, but it is a possibility.
If this could run, then this is the overall solution for all the fields of a cluster spec changes.
I see.
So, Zhongqing, you are seeing the solution we are looking at, right?
No. I'm saying Druid solution.
I have a feeling this
I'm saying Druid solution because they need to rotate the token
okay.
every 24 hours. So my solution may be too painful for them. So if the reps the transport could run, this solution could run. I'm just asking if this solution could handle more scenario, like what I just said. Maybe someday change the URL of the member class.
No, I don't think the URL is allowed to change. So if you change the URL, maybe you need to rejoin the cluster.
That will be very painful because sometimes they don't want to the uh resources in that member cluster be deleted. People won't want it, I think.
Yeah, I probably need to check like our setup, but I guess if that URL changes, I'm not sure if from our end, like from our company setup, if that credential provider can detect that change and to maybe issue a new token. But I think, yeah, even maybe with that approach, as long as we just reread like what is stored in the Karmada secret, we might still get uh like the correct token. That's my understanding.
Yeah, I think he's just thinking a little bit more broadly about this. One way to look at it is what identity you need for some cluster when it comes to building a kubeconfig. And basically that's the API server endpoint token and CA. CAs are usually for 10 years. The tokens can be periodically refreshed, like every hour or 24 hours. Theoretically, the API server endpoint can also change, but how likely that is, I guess, would depend on the specific environment. In our environment, that is possible, but very unlikely.
Right. Okay, that's helpful. And is there any other comments?
So the round trip approach, I think, can work. But one thing that I think we have to do is verify exactly how it will work when you have a watch. I'm not entirely sure. So if we have not looked into that, then I think we have to look into it, because the watch is for a persistent connection to the API server. So I don't know if what happens if the watch temporarily breaking, but then recovering when it tries with the new token. I think we'll have to double check, but I think that solution can work if we don't identify any negative side effects of going with it.
Yeah, that's a good point. Yeah, I think maybe if I try this approach, I would just do some testing and see how it works for the scenario that I mentioned. But I think for us, we also have like the strategy to, rotate the token like certain minutes before it expires. So which means in that short period of window, like both tokens should work. So I mean, I would still check that scenario, but I mean for us maybe it's even like less risky with that strategy.
Mm-hmm.
Yeah,
Yeah.
that's what we do. We rotate before it expires, like 75% we use.
Okay.
Yeah.
Cool. Thanks. Okay, yeah, I think that's all for my issue. Thanks a lot. I will stop here.
Let me see the next Zhang.
Yeah.
Hello, Zhang.
Yeah. Okay. Let me share my screen. Hello everyone, I'm Zhang, but normally I go by ZZ. And just want to be sure, because I know people in China probably is pretty late for you guys. Just want to slightly talking about the proposal that actually Joe come up with at first, but I think it would be like super helpful for us. And what I want to get out of it is like maybe we can review the 6 different metrics we want to add it in for Prometheus, and if you guys feel okay about it, then I'll just go ahead with the implementation. So what we actually why we want to introduce like the 6 different like matrices is actually this has become a problem for our on-call. Because I think when we are supporting for different tenants, I think at least 2 incidents get reported. It's like the cluster, the cluster status becomes off for like 2 minutes, and later on becomes on. So although I know that we have this like kind of like which is kind of like cluster condition cache thing, the behavior of it is still kind of like flippy-ish. We cannot explain why like during some time it's off 2 minutes and sometimes it's like on for another time. So that's why I think we want to add a bunch of more like matrix to we have more observability over like how we can see the SL status for the cluster. Yeah, pause a little bit for that's basically the whole motivation behind this proposal.
Yeah, if we have a cluster that becomes unhealthy, one of the questions our tenants will ask us is things like, hey, for how long was it unhealthy? And as of now, we don't have sufficient telemetry signals to answer these type of questions. Right now, all we have is the current ready condition and the last transition timestamp of that condition. So, which gives us a current snapshot of the cluster state, so like ready or unready, but not enough telemetry signals to know things like how to know about more things about things, to know more about like a cluster's availability over time and whether or not there have been periodic issues with things like flapping due to network issues.
Okay, if no more question, I probably just go ahead with the 6 different matrix. Because I think that would be like super important for us to support like Karmada in Bloomberg. The first one is kind of like having like an average over the time, like what is going to be, for example, it can be 1 hour, could be 1 day, can be 30 days. So instead of, like Joe said, instead of just 1 or 0, that we know it's ready or not, we actually can have a statistics to tell us, the overall health of the cluster. I think this is probably the most important one we want to enhance on. That one actually combined with this health cluster transition in total. Because we do see this like the network blip can affect on the healthiness of the cluster. So if we can see this, if we can even see the health become not healthy and not healthy become health, then we know, okay, there may be, it can tell us maybe there's something wrong with the network issues, but definitely like give us like more insights into the cluster. This one is the kind of like the full cycle of duration, isolates each of the latency to isolate each of the health check latencies. Total. Yeah, this is basically what the describe over here reflects only. Yeah. And this one we'll talk about, and of course, like how many times it takes.
Mm-hmm.
Yeah. Yeah, I guess that's really kind of like want to talk about over here is like if you guys feel okay about the 6 matrix when you're editing, I'll go ahead with my implementation.
This will be very helpful for us, especially for things like dashboarding. A very useful dashboard will be a dashboard that we can look at to see availability of the cluster over time.
Mm-hmm.
Yeah. Right now, because of lack of these type of telemetry signals, there's a lot of questions we just cannot answer. And we want to make our top customers like Antoine and Kai very happy. So we want to be able to answer those questions for them. Also, Mihash and Dao too, they're also top customers.
Mhm.
Any comments or need a little more time to think about it?
Yeah, I'm just here to second this. I think it would be very valuable for customers like us to see like a full picture of what's going on with our clusters. Yeah.
Yeah. Yeah, I don't have any further comments on the metrics. Just one more thing I'm thinking is if we should if we can introduce the matrix linter this time. I know in Prometheus products there is a matrix linter. The linter can validate the matrix name, including the matrix name and the label name. So to make sure the metrics is meet their best practice.
Oh yeah, that's an awesome idea. Yeah. Thanks for letting us know. We can look into it. That would be, I think, very useful so that we follow best practices.
Yes, that we don't need to change the metrics in the future. So
Yeah, will also help over time with making sure all of the metrics consistently follow best practices. Yeah. Yeah, that's an awesome idea. There's a very funny comment on this issue. Someone said we should not do this and just should use their calculator.
Ignore
I
that.
I think a bot posted this. Basically, they looked at the issue and saw some percentages and did an advertisement for their calculator. Okay.
Yeah.
Yeah, you see this, Honkai? Maybe this person wants to replace Karmada with their calculator.
sorry, Joe.
There's a funny comment about a calculator on the issue.
What's this?
It's spam.
Is it just a plain calculator that you?
It is.
That's interesting.
This I'm pretty sure was posted by a bot. Basically, on the issue, there's some references to things like percentages, like 99.9.
Oh my God.
So I guess some bot discovered this issue and just did an advertisement for this percentage calculator.
Yeah.
Okay.
That would
Thanks.
be, that would be me. Stop
Yeah.
sharing.
Okay, next, Kai Zhang.
Yeah. Thank you so much, Joe, for the invite. And I'm Kai. I also work at Bloomberg. We've been working closely with Joe to introduce Mensch Karmada into our Trino platform. I think, Hankai, you have talked to Antoine in Amsterdam. So can I just share my screen really quick? So
Yeah, just like
sorry,
that.
I
Yeah.
don't have a beautiful proposal for this, but sort of like what we're trying to look into is to sort of like suggest a staged rollout semantics to propagation policy so the workloads can propagate progressively. So just to give you guys a little background on our setup, so we do have Karmada control plane sits on top of our two member clusters. And then we propagate Trino service, which will eventually get reconciled and bring up all of the deployment service, things that you would need to bring up a Trino cluster in each data center. And the problem that we're trying to solve is that we have tenants asking for live updates, and then their requirements is that when they trigger a live update by submitting to Karmada control plane, they do not want both clusters to be updated at the same time. So they kind of want to have this kind of like update one data center first and then update different data center later. So Hanka, I think you and Antoine have talked in Amsterdam, and we've explored actually two options. First is with like suspension. With suspension, the idea is to kind of like in the between state, we would suspend the propagation to data center 2. So data center 1 can, schedule the work and then do the update. The problem that we have with this approach is that we kind of don't want to have a stateful either API or some service that watches for the Trino service status or like the Trino cluster status in the controller, because in order to enable this adding suspension, removing suspension, we need to have a watcher or some service that sits outside or in the member cluster, but just like a stateful service And the other option that we were looking into is sort of like having two propagation policies where there's like a parent propagation policy that covers both data centers, and then there's a child propagation policy that only covers the first data, like data center one. The problem with that is that without the preemption and then setting the priority, the propagation policy B, which is the child propagation policy that only targets one data center, cannot reclaim the ownership of the schedule work that propagation policy A has already claimed. And yeah, so that the propagation policy A and B approach sort of like didn't work by our testing. Um, and then yeah, and so correct me if I'm wrong, the current behavior for propagation policy, whether it's duplicated, which is what we use, or weighted, it does not have this like knowledge of how to, either group clusters or just implement an order. It would just like once a Karmada gets the submission, it will just try to schedule the work to all clusters depending on the strategy. So what we're trying to look into, it's sort of something that looks like this, although like, we can there once we have the formal proposal, we'll have to look into like whether it's like an order or it's like a cluster group, and then which like level where we put this sequential so something that we definitely need to look into more, but it's sort of kind of like, supports like a progressive promotion instead of just like scheduling work across all member clusters. Um, yeah, that's pretty much what we're trying to propose. Any questions, feedbacks, or Antoine, if you have anything to add?
Yeah. I talked to Anthony when we meet at Amsterdam. So from the example YAML here, I can see that that's quite that's exactly I want the feature in propagation policy. Just want to make sure that sorry, can you move
Yeah.
your
Yeah,
mouse?
cursor.
I can
Yeah.
see yeah, cursor. Yeah. The
Yeah.
Trino DEVQA01PW is a cluster name, right?
Yeah.
Yeah, okay, sure. Yeah, that's I wanted.
Are you thinking about having
So
an alias or having like a
so
tag?
you
Yeah.
you want to when you upgrade the Trino service, you want the Trino will be update the cluster by cluster, right?
Yeah, currently we only have two clusters, but in the future, we can see ourselves having more member clusters. By having more member clusters, we might be open to support, the idea of like having grouping clusters together. But currently, since we only have two, so we kind of just like use the cluster name to identify, um, like, yeah, the member clusters.
Okay. Yeah. Currently, I don't know how the Trino service looks like,
Mhm.
and so I don't have further comments right now. But
Mhm.
I'm thinking, yeah, this is the proposal. Can it be public?
Yeah, the design doc, it's more for like an internal user story, but we do plan to have a formal proposal that's more like suitable for the open source community, that talks about this problem in a higher level, without talking too much about the specific use case that we're trying to support at Bloomberg. Yeah, but
Yeah,
absolutely we could get that.
yeah.
Yeah.
I want to say currently we don't have a formal proposal
Mm,
because we have a lot of discussion. Uh, for example, we uh, another I would say a former employer from Bloomberg, Li Wang.
mhm,
He sent a proposal also related to the rollout thing,
mhm,
and we have another. Let me see. Oh, Palos, Palos. Maybe today we don't have enough time for Palos to show his work. Um, Palos, can you just say hi to everybody here?
Yeah, hi, this
Um,
is Pavlos Parisis. I go for Adyen in Netherlands, in Amsterdam office. And well, actually, we are going to use Karmada here in Adyen. So we are one of the adopters of the software. And we work with the rest of the guys from the team during the KubeConf about Agora rollout integration and how we can use primitives of Karmada to do progressive rollout. So I opened two PRs, documentation PRs, to showcase to the people how capable are the basic primitives of Karmada.
mm,
cool.
yeah.
Nice meeting. Yeah.
Actually, Palos wrote some practice, right? I think three mode of a rollout. Um, so I won't say we can have a what I wanted is we can have a design the rollout feature in propagation policy for all kinds of rollout, not just for this the specific one. For
Mhm,
like for trainer service, I want a feature that we can support all kinds of rollouts. Like cluster by cluster is just one type. We
yeah,
have another requirements like uh, replicas by replicas.
yeah.
So a
Like
lot of
scheduling three, like the ratio, like the weighted ratio, depending
yeah
on, yeah, okay, yeah. That makes sense. Yeah, that definitely
yeah
is, yeah, a valid concern.
okay.
Yeah.
Maybe
Mhm,
I think I can help to maybe I can help to create another issue to track all the efforts currently in the community, so we can have a overview view on
mhm,
the rollout. So different users are asking different rollout features.
mhm.
So
Yeah, that makes sense. So on our end, we can prep a proposal, and then yeah, we'll subscribe to the issue that when you open it, and just feel free to reach out if you need anything. And we'll be working with Joe closely as well.
okay,
Yeah,
okay, sure, sure.
yeah. Thank you so
So
much. Yeah.
Palos, are you going to show your work next on next meeting?
Yeah, I can show the PRs then on the next meeting, no problem.
Okay. Sorry, Palos. I just removed your
No worries.
your agenda, but I forgot to add to this meeting.
No worries.
Mihas, do you want to go next? I can talk more about my item async. It's okay.
Yeah, I can. I don't think mine will be too long either.
Okay.
Um, okay, cool. So the one that I wanted to talk about, this is an issue that I filed yesterday, actually. So I was doing a failover test with one of our clusters, and I noticed that we currently set the resource eviction rate to be zero point 0.2. So what we expect
Mhm.
is that all of our resources drain at a rate of one resource per 5 seconds. And I was under the impression that we only track Flink deployments, since Flink deployments are the only thing with actual taint tolerations, um, or that timeout after no execute taints applied to the cluster. And then we have a whole bunch of other resources that have indefinite taint toleration set. So this is for like roles or secrets or config maps, and those we do not expect to get evicted from the cluster. But what I'm noticing is that the current eviction queue that's maintained by the taint manager actually includes all types of resources, even if they have indefinite taint tolerations. And so what's happening is, let's say we have 20 Flink deployments, but 600 other resources that are never going to get evicted. Those Flink deployments have to wait for all of those other bindings to get fed through the eviction queue before the Flink deployment resources can actually get evicted. So what I was proposing, I don't know if this is like an expectation, or if this is a bug. To me, it sounds like a bug because the eviction queue probably shouldn't have resources that are not supposed to get evicted. So what I was introducing is essentially a pre-filter step where when we're populating the eviction queue, we should not add a binding that has an indefinite toleration for the taint that the taint manager is looking at for the cluster.
Hmm.
So yeah, I opened up a PR for this, which is relatively small. I had in several tests, but essentially all I'm doing is within the taint manager.go file, I collect all the no execute taints for the cluster that we're currently syncing. And then if we notice that the role binding that we're currently considering adding to the eviction queue is able to tolerate that taint indefinitely, we skip it from getting added to that queue.
Mihap, are you sharing your screen?
I'm not sharing my screen. No.
Oh, okay. I was wondering why I don't see anything.
Yeah. But like conceptually, I think this makes sense, right? Like it's called an eviction queue. Why are we putting
Mhm.
workloads that aren't getting evicted into the eviction queue?
So, sorry, you asked a question?
Well, I'm just asking, like, is this a bug or is this designed working as intended? Because right now, what happens is, let's say you have a propagation policy for, let's say, a bunch of config maps, right? And you set a taint toleration for that propagation policy that states that even if we put a no execute taint on this cluster, we don't evict the config maps, right? So if you put that taint on the cluster, then those workloads will never get evicted because they have that indefinite taint toleration. So the question becomes, why are we bothering with putting these workloads into the eviction queue to begin with? Because we're pretty much starving out the other workloads that actually need to get evicted.
So you are seeing the controller puts workload to eviction list, even that workload had a toleration.
Uh, Correct. So let's say, you know,
Okay, that sounds
so
like a bug, I think.
say, for example, we have, So what we notice is that let's say we have only 20 Flink deployments that we want to fail over, but we have 600 other resources. You have to wait 600 times 5 seconds for all these 20 workloads to move. It seems not like it's something that we intend.
Or 600 resource gets lumped into eviction queue. Oh, that sounds like a bug. So okay, sure. Have you tested the PR?
I wrote it last night, so let me test it today and I'll comment on the PR and
Okay,
let you know what the results are.
okay, sound good. Just CC me on that PR once you have a test result.
Yep, sounds good.
Okay, Joe.
Yep, let me share my screen. Can everyone see my screen?
Yeah, see, sure.
Okay, let me go. So I'll provide a high-level overview of what type of problem we're trying to solve. So we run a managed platform, and on our host clusters, we host multiple Karmada control planes for our tenants. When registering clusters, there's two options, either push mode or pull mode. Push mode is a little bit easier because the controller manager will manage all member clusters, but there's also an option for push pull mode. And when registering a cluster in pull mode, we need to dynamically provision cluster agents that run our host clusters for each registered member cluster. The way it works is we have this cluster registration subsystem, and one of the components in that subsystem is the cluster agent provider. And for each member cluster register in pull mode, its job is to dynamically provision the agent that will be managing that cluster. However, today there's no native support for running the cluster agents and this type of topology on the managed platform, which is why I'm asking for support, for native support for this type of problem. One of the responsibilities of the Karmada agent is to do all of the plumbing required to register a member cluster of the Karmada control plane. However, as part of our managed platform, we have other components that handle all of that responsibility. So at a high level, what I'm asking for is something simple like a flag that we can set to skip this part so that the cluster agent can be enlisted in the cluster registration subsystem and that everything will just work smoothly. That's the high level overview of this request. And any comments, questions about this?
I can get from this. You want a flag that can disable command agent to register.
Yeah, the registration.
Yeah.
Yeah, because as part of our managed platform, we have other components that already handle that responsibility. So today, by default, the way the agent will work is by, for registration, it will create all of the RBAC resources in the member cluster, and then we'll register the member cluster with the API server. Kind of like similar to how nodes get registered for a Kubernetes cluster. So my request is just to add a simple flag to turn that off. And once we have that, then this will work very seamlessly as per our managed platform. And the main rationale for this is because we have many tenants and not all of our tenants have the same scale profile. One of our tenants runs at very large scale, and for them, we have to do all we can to optimize performance. And to achieve that, we actually are doing a lot of work for scalability testing. So soon we should have more data to inform whether or not we should register the member clusters in push mode or pull mode. But one of the conclusions from the most recently published scalability test was a better performance profile when using clusters registered in pull mode as opposed to push mode. So we want to try that out. That's basically the request at a high level.
Okay, that makes makes it to me.
Okay.
So, do you have any idea on the flag design or?
Naming is one of the hardest problems, right? What I'm thinking is something like skip cluster registration, and for backwards compatibility, it will be off by default. But for our use case where we want it turned off, we can just set it to turn that functionality off. We can come up with names, and then you can let us know what you think.
Okay.
Yeah, the naming we can figure out.
Yeah, naming is harder than coding.
I know, yeah. Okay, thanks for validating this request. I will be working on this with one of my teammates, so very soon we'll see a pull request from us. And then you can let us know what you think about the name we come up with.
Okay, sounds good.
Okay, all right, thanks.
Okay, see.
Okay,
So
guys.
let me
Thank you so
see.
much.
See you.
晚安，早点睡觉。
Thank you.
中午好，
拜。
拜拜。
Goodbye. Goodbye.